All right, you guys, this is very unique. Unfortunately, I'm attending a funeral today. We'll talk more about that, maybe not, Tuesday. So just to introduce myself, my name is Mr. Kleefish, and welcome to the final trimester. Tons to talk to you about. Normally today I would introduce you to classroom rules and all that. So just to introduce myself, let's see if this even works. Here we go. Hi, I'm Mr. Kleefish. So, if you dare to stick around, we will have a great journey. Look at that. Infinite me's. Anyways, yeah, we'll talk a lot Tuesday. Let's get down to the math. Unfortunately, yep, lesson number 1, here it comes. So, if you didn't have me in the first try, the way I talk and the way your previous teacher talks might be a little different. But I'm going to try to make it as easy as possible. So here we go. Pre-Calc Unit 8 starts off with a review of graphing sinusoids. That's a fancy word for simply sine and cosine. And again, I'm assuming you have a general knowledge, and this is supposed to be kind of in your sweet spot as far as your parent function goes, but let's get started. So, recall, here's some formulas. Amplitude is the absolute value of A. So where do we get the A? It's the leading coefficient. So if that's a 1, there's no change. What is this B? It's the coefficient inside the parentheses, and that is very, very significant when we're talking about period and phase shift. Now, phase shift for my students, first trimester, Pre-Calc A, this whole phase shift thing is going to be a little new. We didn't need it because all they did in the first try was throw a few negatives at us, and we needed to know that that would reflect it over the y-axis. Now they're going to throw some changes at us. They're going to put something other than a 1 there, or other than a negative 1. So be prepared for that. And what the heck is phase shift? We'll talk about that. And then the letter C, of course, right there. That's part of our phase shift formula. And that just that means left or right. And then D, you know, you go up D, down D, and there's the rules right there. So let's just get into it, and hopefully this will make sense. So y equals sine of x. Again, you can always, and here's another thing, check this on graphing calculator, you can check it on Decimos, but you're going to be expected to understand how to do this without any of that technology. So, this is our parent function, and we should know, and I'm not going to go through every little step like I did first trimester, but it goes through the origin. Now, if that's pi over 2, you know, we can understand, and I'm not trying to bore you to death, but here's a little lesson. Well, nope, I'm not going to do it. We just know that if this is 1 and this is negative 1, we know from our parent functions that it's going to go up to 1 and down to 0. Then it kind of does the same thing over here, but it goes down to negative 1 and goes back up to 0. That is your parent function. Now, if I want to get really fancy, maybe you guys want to get fancy too, because this is going to get really messy by the time we're done when we do all these little changes. So, one step at a time. So now, I'm going to go with y equals sine of 2x. So what's the only thing that's changed? That. What is that? A is 2. Hopefully you know by now, after Algebra 2 and Pre-Calc A, that's a vertical stretch factor of 2. You don't add 2, you multiply by 2. So what I like to do is think, okay, that's a 0, stays. That's a 0, stays. That's a 0, stays, because 2 times 0 is 0. That's a 1, so we double it, goes up to 2. It's a negative 1, so a double it goes down to negative 2. And I've got all I really need to get going there on that one. So, the next one, let's pull out a green color here. We've got a couple different changes. So, as you can see, I'm making incremental steps here. This is the same as this, so really all we're going to do is think about this green guy, which is x. Notice there's a 1 here, so no worries there. It's not going to change your period. Oh, quick review. Notice it takes a total of 2 pi to go through one cycle. That is called the period of sine. And that's the normal period. And here's a big hint. Notice this formula, period, is 2 pi over the absolute value of b. It gives you the normal period right in the formula. So take that to the bank. All right. Now, if b is something other than 1, it's going to change the period. If I put a 1 in there and follow the formula, that'd be 2 pi over the absolute value of 1, which is 1, so it didn't change anything. So that's going to stay the same. The only thing different is we're going to move this, and remember what this means. This means we're going to move right pi over 2. Now you got to think in terms of these chunks. That's like 2 squares. So we got to move the blue one to the right 2 squares. So I'm going to move that point to the right 2 squares, 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 and hopefully this will look just like the blue one, just bumped 2 squares to the right, or right pi over 2. What's the last change? The last change is going to be, oh, come on. Oh no, can't grab my highlighter. Here we go. All right, we got it. Orange. Well, all you're going to do, because that's the same as that, this is the same as this, I'm just going to bump up our green one up 1 unit. So this is going to be up here. This is going to go up to about there. That's going to go here. That's going to go here. I better start drawing this in, or else I'm going to get myself lost. And then that goes up to here. And so really, you can see the orange one is just the green one bumped up 1. And you don't have to be perfect. We're just kind of going over the rules here. All right. So let's go to this one, because this is going to be a little different. And I'm going to have to keep going up here to the formulas, so here we go. So the first thing you do is you look at this and you ask yourself, what in the world is the parent function? Well, you better be able to tell sine. So hopefully, and I worked hard with my students first trimester, just so you guys can kind of have an idea of where this goes, but the more you do, the easier it gets. So there's your parent function in pencil. So I'm a one step at a time kind of teacher and thinker. So I'm going to take that, and I know what to do with that. That's going to go here. We just did these here, and just going to go like this, and I made it dotted. Okay, that means I ain't done yet. Now we got a little situation in here. And the first thing we're going to do here is really take a look at this. Notice that's no longer a 1. Our period formula is 2 pi all over the absolute value of b. That's b. The absolute value of 3 is just 3. And so here's how your brain needs to think. And this is where students who haven't done this ever, or maybe they've been doing it a while and it still bothers them, we have to think about the original period. Now, I also want you guys to notice that a lot of teachers would go like this. Now I'm going to erase it in a second, but a lot of teachers, instead of showing y equals, and I'm not saying they're wrong, it's just different. A lot of teachers go from here to here to here, and then they go down, and then they go up. So they pick this window from 0 to 2 pi, and that's fine. But on this next little step, I like to go just like I did. I like to go from the middle halfway that way, middle halfway that way, and here's why. When we change the period, I think it's going to be easier to understand what the heck's going on. So here's how I explain it. So we notice the normal period is 2 pi, with 1 pi on the half of the total pi on this side, half of the total pi on that side, and my brain likes that. Brain likey. So now, if my entire period is 2 pi over 3, this is going to go back to pre-calc A. What is pi over 3? That's 60 degrees. If you don't remember that, you cheated your whole way through pre-calc A. Times 2 is 120. That's my entire period. Now we got to use some common sense. That means when I draw this next one, half of it is going to be 60 degrees, half of it's going to be 60 degrees, but notice this is in terms of pi. But we can use some common sense. Pi over 2 is 90. So 2/3 of the way would be right about there. That's 60, I'm guessing. And I'm just going to duplicate it over here. 2/3 of the way would be right about there. Now this would be pi over 4, because that's half of 90. So I know to go a little bit more. What that means is this dotted one needs to get squeezed in new walls. Now I talk about Star Wars, and I think about the old scene where they're stuck in the trash bin, and then the trash walls, it's a trash compactor, and that's what's kind of happening. It's taking this dotted wave and it's smushing it like an accordion. So this wall comes into here, and this could get really messy, but it comes into here. This wall moves into here, and I need to duplicate this drawing in this little, so it goes up to 2, down. I need to do the same thing between here and here. So the halfway point's right there, so I'm going to go there. Now I'm going to go, ooh, already got off to a bad start, up and down. This one goes down to -2 and up in this time. So I got to do the same thing in this window. And there it is. So I'm going to color that so it sticks out in my head, because it's getting messy. But I'm not done. All I did was I changed the period. Okay. Now, the phase shift, I told you earlier, is a formula to figure out which way to move this green chunk of the sine wave. So I'm going to remember, this is my A, this is my B, that's my C, that's my D. The phase shift is going to be C over B. Now sometimes they include this little plus or minus. I don't, because, I'll explain why. Our brains by now should look at this and already know that that means right. So whatever we get here, we're going to move right that far. All right, so what's C? Pi over 2. What's B? 3. Now you guys need a little algebra lesson because it's been a while. But let's go like this. 10 over 2 divided by 5. All right, let's experiment. What's 10 over 2? 5. So 5 divided by 5 is 1. Now let's experiment. Let's try this a little differently. Let's have this thing go underneath that line and slam up against that 5. So that would turn into 10 over 10. Do we still get 1? Yes. So those little tricks are the things that separate students from understanding the material and not understanding it. Because notice we got this 2 and we got this 3. So if we just let that thing drop underneath and multiply, we get pi over 6. So we got to move that entire green guy right 30 degrees, which, use your power of estimation. If this is 45, 30 is right there, so it's like 1, it's right about that far. So if we kind of do a little power of guesstimation, I'm going to move that here, that, oh boy, here-ish, and I better draw that in there before my brain starts disintegrating. Here to here, here right about to there, there, about 30 degrees would be about that far. Now, it should be the same graph as the green one, just bumped to the right a little bit. Okay, and we're not even done. We still, after all that stuff in there, we still got to move that orange one up 1. So for the final kicker, we got to move that orange one up 1. Now this could get interesting. So that goes up there, that goes up to here, this goes to here, so down and up. This moves up 1, this moves up 1, and so it would look something like that. Perfect? No. But are we getting it? I hope so. Let me turn the page here. All right, so example 3, big lesson today. Don't run down to the counselor's office. You guys got this. But yeah, Unit 8 doesn't start out with little patty cake math. So here we go. Look at this. Sine. Like, okay, better know what that looks like. Here it is again. Up to 1, down to 0, down to -1. So there. There's my parent function. Okay. Now, we look at this, and pre-calc B, I don't know why I'm writing this. Well, okay. Pre-calc B introduces a new way of kind of introducing a problem to you, and you have to wonder, what is that? Well, question, do you have to distribute the 3? Can you? And we have to investigate. So let's experiment, and let's actually distribute this to there, and let's take a little peek. I'm just going to write y, so I don't have to write L of x every time. Y equals sine of 3x minus 3 pi over 2. All right. So here's the thing. If this is the way it is, my A is 1, don't have to worry about that. My B is 3, My C is something kind of crazy looking. And there is no D, so I don't have to move it up or down at the end. So let's focus on B and C right now. Remember, the period for this one, if we actually did the calculations, the formula is 2 pi all over the absolute value of B, so that'd be 2 pi over 3. Now, the phase shift, if we follow the formula, is C over B, and again, we know this is minus, so we know it's right. C is 3 pi over 2 over B, which is 3. Let's use that little trick. So we'd get 3 pi, 2 times 3 is 6, which is just pi over 2. All right, now let's use our noggins here a second. Do you see how the phase shift after all that work ends up being, because of the negative, it ends up being right, pi over 2? Couldn't we have just gotten that right from here? So as far as like phase shifts go, no, you don't have to distribute that through. This is just like it's always been. That's just right, pi over 2. But obviously you can distribute the 3 through. That works also. It's just a lot of extra work. Now let's talk about the period. We got 2 pi over 3. So what if we were calculating the period now, and we accidentally thought of this as just a 1? Then we'd go 2 pi over 1, which is 2 pi. And we know, after distributing it, that this 3 does affect the period. So my point is, do you have to distribute this to figure out the phase shift in this situation? No. Do you have to distribute this to figure out the period? Yes, because we know it can't be 2 pi. We figured it out. It's 2 pi over 3. So with that being said, remember what this is. This is 120 degrees, and that helps us because that means my original, there's my Star Wars trash compactor walls. That's a total of 360 or 2 pi from there to there. Half of it's 180, half of it's 180. This needs to come in and this needs to come in, so that half of it is 60 and the other half is 60. So I think this is the hardest part of the lesson. So if you're hanging tough now, the rest is going to be a lot easier. So where's 60? Well, that's right here-ish and here-ish. Just shy of 90, 2/3 the way, 2/3 the way. So I'm going to make this dotted, and I'm going to make this dotted. And I need to draw the same wave in this window. So this goes down to 1, -1, and up in this time. So this is going to do the same thing in less time. This goes up to 1 and down to 0 in this window. So in this window, it needs to do the same thing. All right. And that's it. All right. So, a little tricky. So, number 4, a new way of just talking about period. So, they're going to come at you, so you have to think a little different. Keep in mind that the normal period for sine and cosine, I haven't reminded you of what cosine looks like, but it's 2 pi. Don't forget that. So it says, what is the period of da-da-da-da? Well, it doesn't say to graph it, but I thought maybe a visual image would help. But, so let's go ahead and take a look at y equals sine of x. Again, practice makes perfect. No, it doesn't. Perfect practice makes perfect. There you go. So there's your parent function. There's a measly little 2 there. Well, what is that? That's b. What's that going to change? Well, first of all, phase shift only happens when you have this situation where you have a b and then a c. So we don't have any phase shift. The only thing is we got a period that's going to change, 2 pi over 2. Using our formula, 2 pi over the absolute value of b. Don't fall asleep. All right. So what does this turn into? Pi. So, what does that mean? That means the whole period is pi. That means that's 180. So this wall needs to squeeze into here and here. So this would go down here, up here. So it's the same drawing, but it's compacted and it's bending for us. But it's saying, how do you talk about it? Well, the period is pi. What happened to it? Well, the original period is 2 pi. So the question is, how many cycles are in 2 pi? Well, if I fit this in pi, then I could fit another one. Here's where it starts on this side, and this would go up to here, and I could fit how many cycles? Or, yeah, so I don't know, 2. Because there's one period, there's another one. There's a cycle, there's another one. So after you make the changes, how many cycles are in the original 2 pi? Well, you could fit in 2. All right, a lot of talk there, but here we go. What is the period of this? Well, again, there's our parent function, y equals sine. Ruh-roh, got a fraction, don't panic. 2 pi over the absolute value of b would just be 1/2. Now, you guys, basic math 101. What happens if you have 10 divided by 1/2? You got to multiply and flip it. So this is the same thing as 10 over 1/2, which means you would go 10 times 2 over 1. You flip the fraction in the denominator. So same thing here. We're going to get 2 pi times 2 over 1, which is 2. So now it's 4 pi. And notice, if b is a whole number, it shrinks the period. If this is a fraction, you put the fraction in the bottom, it actually stretches the period. It gets wider, longer. So, use some common sense. The original was 2 pi from here to here. But now it's saying stretch the whole thing out to 4 pi. Well, if this has pi, the original, on that half, and this has pi on that half, that means we got to stretch this out. This wall is going to have 2 pi on this half. From here to here, I'll make this dotted so it's different. Maybe I'll make it green so it's different. Then this has to go to, so that our whole period is now 4 pi. So, if we actually drew this right here, everything gets stretched out. So notice on the original one, it goes down to -1 and then comes back. This is the halfway point. It goes up to 1, back. That's the halfway point. So we got here to here. What's the halfway point? That'd be right here. So I'm just trying to duplicate this, and it goes like that. Then I need to do the same thing here. This is the halfway point between here and here. The halfway point between here and here is here. So you can see I horizontally stretch that thing. But now it says how many cycles in 2 pi? Well, if we stretched it out, there's only half a cycle, a half of a cycle in the original 2 pi period. All right. So, notice the answer's kind of staring you right in the face. So, and the answer's staring you right in the face. Anyways, all right. So, a lot thrown at you. I realize that. I think we're almost done. You can see you got a homework assignment right here. If you don't have an online book yet, you can go up to the front of the room. There's hardcover pre-calculus books. Okay. Now they're going to come at you differently. The graph of y equals sine of x is stretched vertically by a factor of 2. That's a fancy way of just saying a is 2. So let's make that adjustment. So we know at least we're on a quiz or a test and we're going for partial credit. You better be able to do that. That's 2, vertical stretch. Now this is kind of interesting. It makes 3 complete cycles in the interval 2 pi. Well, remember our little trick? Now we're going to make that adjustment. We know that that's going to be sine of 3x, and we're going to stop right there and have a little talk. All right, I'm going to add just a little bit to that explanation because maybe it lost you, but remember the original period formula is 2 pi all over the absolute value of b, which is just 2 pi all over b. And if you remember from our previous 2 examples, if this is a whole number, it's going to shrink it down, so you're going to get more cycles, not less. If this is a fraction, it's going to stretch the original, so you're going to get less cycles, not more. So with that common sense in mind, the question is, what do I put in there, a whole number, or do I put a fraction in there if I want more cycles crammed in the normal period? And the answer is I want a whole number. So that's a different way of saying let b equal 3. So with that in mind, that's a little trickeration to help you understand what b is. So hopefully that helps somebody. All right. So this says shifted up 4 units. I'm going to save that for last because I know that's my D, and I'm just going to add a +4 in a second. This is what I really want to concentrate on. And this is why you're introduced to the new way of thinking of these things. So what I'm going to do, how do I make this right pi units? Well, remember we said that if we write it like this, and then right means minus, whoopsie, x minus pi. That's the new way of saying move it right pi, but then that b actually comes in here, causing b to be 3. It's just a new place to put b. So then we can do that right or left adjustment a lot easier. And then the up 4 is just up 4. That's it. So that's a little tricky. All right. Next one. So let's graph this. again, I don't know why I didn't do any cosines, but sine, we got to start with, we're almost done. So we go like that, go like that. There's my parent function. There's a 2. That should go up here. That should go down here. And you guys should be getting better at this. So there's the easy part. Now I'm going to go ahead and take care of this right now. Actually, no, I'm not. I'm going to take care of this. Because again, like I said, I like this being half of the entire. So I like the walls coming in, figure out what that looks like, and then I'll move it right, pi over 2. So what is this? Well, that's my b. So the formula for period is 2 pi all over b, which means 2 pi times 3, because I flip this and multiply, which is 6 pi. Okay, think in terms of halves. That means this last one that I just drew goes from pi to pi, negative pi, but that's a total of 2 pi. Now I need a total of 6 pi, so that means I need 3 pi on this side, 3 pi on that side. I'm just going to kind of guesstimate chunks right about here, and then we'll throw 3 pi out here. I'm just guessing. So we got to take this one, and somehow, and I'm going to go green, and here's my adjustment for this. This down and up needs to take place between 0 and 3 pi. So 1.5 pi is right there. So that means that's going to be the low point. That's the new halfway point. Now I got to do the same thing here. This goes up to 1 and down. I need to do that same thing here. What's half of 3 pi? 1.5 pi. So that's my halfway point. So that goes up and down. And because my new walls are right here. And there you go. Okay. So, last one. Number 7. Cosine. Cosine, the parent function, looks like this. We'd have a lot of fun if I was in class right now. Alright. And so now let's mess around with that. So, what does that 3 do? Well, that moves it. This is 1. That's 2. We'll put that up here. This stays, this stays. This is negative 1, so that's negative 2. We'll put that down here, and this drops down here. So that goes to here. All I did was vertically stretch that thing. Okay, now here comes an interesting little twist. So notice how B, for the first time in your lives, is pi. So, hint, pi is 3.14, so it's close to 3. So what that's saying is, we're going to take that, just give me 1 second. So, if b is pi, and we stick with the program and we use our formula, we know the period is 2 pi all over b, which is pi. Now, you guys got to listen. The period is always in terms of radians. Now, my pre-calc A'ers, a long time ago, we had this long discussion, and we said 1 radian is approximately 60 degrees. Now, I'm not going to reteach that right now. I'm just going to tell you. So keep that in mind, because when we simplify this, we get 2. And you're like, what the heck is 2? I don't see a 2. Well, that's 2 radians. So that's approximately 120 degrees, which means halfway I need 60 degrees on that side, 60 degrees on that side. That's what's telling me what to do with this guy. So remember, this is now pi over here, negative, well, it's pi over here also, a total of 2 pi. So what I need is 60 on one side, so this wall needs to come into 60, and this wall needs to come in to 60. I'm going to make a new wall nice and pretty. And then, where's that dot? Right here. Somehow, I've got to squeeze this guy into this space. So I'm going to start here, and I'm just going to go for it, up, and then come down, and then there she is. Now I'm going to make that green so you know what our last step was. There it is. And then, look at this, guys. We got to go +1. That means left 1. But again, left 1 what? Left 1 radian. So they're going to mess with you a little bit with these sort of units. What's 1 radian? 60 degrees. This is going to be crazy. So I'll get out an orange marker. 60 degrees is, what is it? It's a little more than 1 box. That's 45, so 60 degrees would be about right there. It's like 1.5 boxes-ish. So we got to go left 1.5 boxes. So right there, we'll put it right about there. This 1.5 would go right about there. I'm just kind of guessing. And that would be right about there. So that would go like this, and like this, and we're done. All right. So, if this thing just messed with you, and you are just a glutton for punishment, you can go to Schoology. You just did, but then you can actually watch my pre-lesson and then watch my lesson if you want to slow things down a little bit where you can have it sink in. And yeah, so here you go, guys. Give it your best shot. That's all I can ask. And have a great day, and be nice. Talk to you soon.